Okay, help me solve these then. So we've got our Python code window. Let's check that it's working. Nice and slow, we can see triangle into the hexagon, which means I've broken it, haven't I? It should have the different parts. Then we've got the triangle. Now we'll maybe improve this so we've got separate pieces of code, separate problems for each. So there's what it's doing. We've got the triangles there. You want to speed it up, you can change the speed here to a 7. And it'll go through them a bit faster, okay? But it's easy to see the patterns from the beginning. So let's look at the first challenges. We've got a pentagon. So we've solved the pentagon here. There's the code for the triangle. We know it's got 3 sides. We're making it draw 50 pixels in length, but then 120 degrees. Why is it 120 and not 60 for an equilateral triangle? Can anyone remember? Yep. Good. It's the angle on the outside that we're turning. We're not turning the internal angle. How could you get it to turn right only using the left function? Yep.
You make it go all the way right until it's facing.
Yeah. All the way right?
All the way left.
All the way left. Okay, so we can turn like the opposite or the negative angle to go left. So there is my cheat for the pentagon. It's the exact same apart from 2 things. What's different? Write this here. Anyone? What's that? Yeah. Yeah. This part? Yeah. So why is it 5? 5 sides. Why is it 360 divided by 5? Yeah, need to turn 360 degrees on the outside. So 360 divided by 5. Who's got math skills? You can tell me what that is. You get the calculator to do it? 72, alright, well remembered. So you could put 72 there. Alright, now but the good thing about this, and maybe you can figure this out later, is most shapes have sides. So watch what I can do here. Input, oops. Enter number of sides. I'm going to make the forward go just about, well, let's make it 20, because if we do too many sides, it could be too big. Okay, who can tell me what I need to change this to and this to? Who can figure it out? As soon as I do it, you'll go, of course that's what it is. Who can guess? Why did we do 360 divided by 5? Why was it 5 we chose? Yeah? Because there's 5 sides. Sides. Is there an echo in here? Who can figure out what to change that to? Anyone figure it out? Yeah. Angles, very good idea. Not correct. You're on the right track. I need to change it to a word. Hint, the word is on the screen at the moment. Yeah. Good man. Sides. And if I change this to sides, and then we press play again, watch what happens. Look, it stops, and it's down here with a little flashing indicator saying enter number of sides. Who can tell me a side that's quite ridiculous but not loads? Yeah.
160.
What do you call that shape? So you don't know? Oh, that one? Yeah.
Let's go for pencil.
A dodecahedron?
Not a 3D shape.
Is it?
Yeah.
What's a what? That's 10, isn't it? 12. Decagon. Okay, let's go for 12. You can verify if it looks correct. It's going to be circular. There you go. Did you see it? Pretty quick.
You went well this triangle was still there.
Yeah, well, we can change it if you want to do. Well, we need to do other things. I'll change it so it's better, so that it sleeps. Okay, so there's the first 2 challenges and how and why the loops work. Next one, we have to look at the square of stamps and remix the code to produce the stamps for the other turtle. So there's the part that loops 4 times in a square. So we'll copy paste that. And we can put the hexagon stamps down here. Paste. How many sides in the hexagon? 6. So change that to a 6. Using our math skills. 60, because 6 sixes are 360. So we change the Tommy dot left. So we watch it. This one's still going to ask for number of sides. 26, what do you call that sheet? A 26-sided sheet, there you go. The more you put, the more circular. There's the hexagon stamp working. Okay, keep problem solving. Pentagon spiral. So we've got the triangle spiral there. Because it's showing you that you can do it 2 different ways. There's many ways that you can do it. So we've got a loop and then another loop within inside that loop. What do you call the place where birds live? Don't say the bird park. Where do they live? Nest. So when you get a loop inside another loop, it's called a nested loop. Who can work out how many times all of this internal code will run? Yep. Why?
Because it does it 3 times and then there's 3 times.
Good. So it happens 3 times, but those 3 times happen 10 times. Simple math. 3 times 10. Look at this. Oh my goodness. We've got no code for our Pentagon spiral. So let's take the first one. Let's try it with the first one. We'll paste that in there. So we've got 10, which just means there's 10 triangles in that previous one. So just let's leave that as 10. Yeah? How many sides were in a triangle?
5.
In a triangle?
Oh, 3.
3. So we want 5 for the Pentagon. Agreed? Tommy goes forward 10 times I, which is why it goes a little bit further forward each time. Because every time this goes round, I keeps counting up, like your fingers, to 10. So what's 10 times 1?
10.
And then the last time it goes, what's 10 times 10? So it's going much further each time it goes around that loop. But the triangle was 120. What do we need here for the Pentagon? We worked it out earlier. 72. Nice one. So let's try that. So we'll get triangle. What's the number of sides?
561.
161. It's just going to look like a circle, and it's going to go off the page for about 15 minutes.
So the more number of sides, the bigger it is.
Yes, correct. And it will take a long time. There you go. Hexagon stamps. We get our triangles. We're going to get it twice because we've got 2 pieces of code doing the same thing. Here's our second triangle. Same thing, done a different way, producing the same outputs. Here comes our Pentagon of Pentagons.
Pentagon spiral.
Pentagon spiral, yeah.
It can look like a hole. It looks like a dog.
And then we've got that maze. So we've got to produce this.
Me and MJ did that.
Good. But you can help us solve it.
I've forgotten what to do. Not just
Okay, looking at it, what's the pattern?
easy. It's 2 times 3.
It's moving forwards, turning left, moving forwards, turning left, moving forwards, turning left, moving forwards, turning left. It's just repeating. So let's look at the code and see why. Now, what I'm going to do is so that we can make our lives a bit easier than watching us, I'm going to type 3 speech marks. You see it go red. And I'm going to go back to the very beginning to here and type 3 more. And what that means is that the computer will just ignore it and it will go straight to that piece of code. Okay, so we've got that spiral. We've got the spiral again there at a different place. Okay, so let's look for it and figure it out. So there's the maze-like pattern. And you've only got to change 1 piece of data
Ooh, I remember.
to solve it. Yeah, help me out.
Actually, no, I don't remember. Is it 3?
For this one, 3 here.
Yeah, it's 3.
Okay, let's try it. Let's try it.
That's what I did.
That's what I did too. Okay, I'm cool.
So there is the practice 1. There we go.
Oh,
Why does that work?
because you keep on going left and right.
So the first one only went left twice, didn't it? Whereas that other one wants to go 3. Are there other ways to solve it?
Actually, no.
Yeah, probably. Did that one work?
Oh. Yeah.
Perfect. Let's move on. All right, we'll leave those 3 comments in. The next one is a pentagon of pentagons. Oh my goodness, that's going to be tricky. So same again. let's put those 3 speech marks in to ignore this piece of code. 3 more there. Alright, so it'll just run here. So we've got the output to be shown there, and then we've got this last challenge to do, like a staircase. Oh my goodness. Should we start off with a pentagon?
Yeah.
Okay, we had that earlier, didn't we?
Yes.
So let's get the pentagon very early on, wasn't it? Where did it go? Pentagon. Square stamps. This one, oh, we changed it, didn't we, to do that?
I guess it was on 924 and 1 on.
Good guess. Good guessing. Okay, so pentagon, 5 sides. Tommy, forward 360 divided by 5. Okay, so that's doing a pentagon. What would happen if we copy that and put it again here? Now, one little hint, we've got to put that and that. Now, we're going to get some errors here. That's all right. Let's figure them out. Are we...
You need to.
Right.
Oh, it's getting thicker.
It's getting thicker, it's drawing. Sorry?
I think you need it to move forward. Yeah.
Forwards? Different?
The second move.
Alright, let's try turning a different angle each time.
No.
How's that?
No flower. No.
It's like a flower.
Way too
What is different between that one and this one?
small. Size.
The sides are smaller, aren't they?
And this one, those pentagons are upside down and smaller than the big
They're
pentagon.
upside down, smaller than the big pentagons. Alright, so how can we change that? Let's try. Let's try making it move forward 40, 50. We'll try 50. Let's see what happens. We can experiment. It's not going to break anything. How's that?
Whoa. Yeah, whoa!
It's close, isn't it?
I can't tap. It looks like a turtle.
What do we need to do? What do we need to do to change it before we start? Yep.
You change the other forward 20 to 50.
The other 4 to 50, it's just going to... Well, let's try it. Right, we'll try it and see what happens. So we're just going to get a bigger version of the one we drew earlier, which is cool. It's like a pattern, yeah, but it's not correct.
Wait, that's so cool. It looks like a football.
Yeah, it does look like a football, yeah.
It looks like my face.
Thinking about it, come on, let's look.
Okay.
When he starts drawing the smaller patterns, how do we get it so that it's not turning the same direction? We could do something right here. We could do Tommy, dot, right. Let's try 10. But then at the end, before he starts the next one, Tommy, dot, left, 10. So that he's pointing back. Let's try this. How's that? Is that getting closer?
Yeah.
Okay, what angle do you think we need to change this to then?
90.
45, 90, good tries. Let's see what happens. How's that?
Yeah.
It's close? Should we try 90? Let's try 90 then.
Oh yeah, that's it. I called it. Yes, it is. Be quiet. I said it is.
Close enough.
90. 100. Try 100.
100, yeah, okay. It's close enough. We've got the right
Yeah, it's
idea.
close enough, see?
So this one,
This one's easy.
okay, you can help me solve it
Yeah,
then.
okay, I will.
Alright, and then you've got some challenges you can
Can I
try.
use a whiteboard marker to help you, please?
Well, you can just talk me through it, just coach me.
Please, it'll be a lot easier with a whiteboard.
Well, I'd rather we just coach me here.
Oh, well, because I was just going to draw it on the...
Well, that's not going to help.
Well, so you just write, you write, so yeah, you write that, and then you write number, wait, what's the number, can you go down? Can you go down, please?
Okay, well, wait a second. Let me just
see
put
what challenge it is.
Tommy,
Like, what number challenge it
it's
is.
the last one.
Okay, so do the last challenge. Write that, and then it should do it.
Don't you keep on making the square?
Right, Tommy, don't do last challenge. Right, Tommy, don't
Tommy,
do
don't do last challenge. Yeah, good try.
No, it
Okay,
won't work. I'm
how
telling you.
many sides are in that shape?
20.
4. 4. X and range 4. Easy peasy. How do we draw a square? Tommy, dot, forward. Let's make it 10. And then what do we want? Tommy, dot, left, 90. Okay, and then when he moves on to the next square, he's gone a little bit right and a little bit up without drawing. So how do we lift the pen? Tommy, dot, pen, up. Tommy, dot, forward, 10. Now, we may have to make it forwards. Right 10. We might need to experiment a little bit here. Tommy dot. Now there's Tommy dot up 1.
It's Tommy dot forward.
Tommy dot forward 10. Let's try it. But then after that, we need to do Tommy dot pen down.
And then for X and range.
Yeah, and then it will start again, won't it?
Oh, wait.
Let's see what happens. Now he's away down there. We'll close.
Say start at
Maybe
like
Tommy
Uh-huh.
dot
0, 0.
Now we need to make sure he is pointing up. So Tommy dot left.
Change colour each time.
Yeah, it changes colour each time, doesn't it? Now we won't go so far down. Let's go to negative 100, negative 100. So we go there. Oops. Okay. Can anyone suggest? I mean, it's still cool. It's like drawing like a. It's almost like a bridge.
Cardboard box planks. It's like a rainbow.
Oh my
Okay.
gosh.
Now it's doing that because each time it's turning a little bit.
Whoa.
Okay.
I know that.
Thank you. Thank you. Thank you. So you can hack around with that. It's just because at the end we're maybe turning too far, not turning enough. And after this, right forward 10, we need to do the opposite so it goes back where it is. Okay, so we would do Tommy dot left 10. Probably don't want to move, maybe move a little bit further forward each time. So let's see what happens here. Okay, you can see it going. So it's the same idea. We just need to
It needs to be moving across more.
move right more. Okay, let's try 20 then.
Yeah, that will work.
Forward 20, left 20. Let's try that.
Yeah, that's
Yes, that should work.
No, it needs to be less, like 15.
15. Okay, because
45.
45 is too much, isn't it?
Oh, yeah.
Too much. Too much, Kendrick.
Just do this one to 15.
Yeah, so this is too
15.
Shoes on my feet.
How's that?
Yeah.
No.
Yeah, that's it.
It's the same idea, isn't it? Okay, we could just mess around with the math. If you look at it, you can see that the next one touches the next one, so it should be half the distance that you're moving. So that is the solution to all of those challenges there.